change refers to the alteration of temperature and weather patterns on a global scale. The shifts in climate have significant implications for various aspects of human life and natural ecosystem. Human activities, primarily the burning of oil, are the primary drivers of current climate change. The combustion of these oils release greenhouse gases into the Earth's atmosphere. These gases, including carbon dioxide, trap heat from the sun, leading to an overall increase in the planet's average temperature. According to the global greenhouse gas emissions data, 62% of overall carbon dioxide emission comes from the combustion of fossil fuels such as oil, coal, to generate electricity. Although the oil and gas industry has been one of the major contributors to climate change, they also cannot run from experiencing the after effect of their own doings, thereby affecting most of their operations. The impact of climate change in the oil and gas sector affect various operations, including its industry, production, and supply chain.
Over the years, climate change effects such as increasing temperature and rising seawater level has been a threat to a global economy and industry. Oil and gas industry also cannot escape being affected by this climate issue. The obvious issue sparked from the climate change is the oil and gas industry are increased in operational challenge and oil and gas getting threatened. Firstly, climate change affects and threatens oil and gas companies by making it difficult to operate in an altered environment such as increasing sea level. According to Cross and Crossman in 2013, most of the oil and gas infrastructure is situated offshore, in low-lying coastal areas, or in other regions where extreme weather events are more likely to occur frequently. Extreme weather has already resulted in record losses and devastation. For example, in low-lying coastal regions like Saudi Arabia and India, some of the world's largest oil and gas facilities are vulnerable to coastal flooding and storm surge. Rising sea level, ground subsidence, and erosion, which makes the existing infrastructure more susceptible to periodic or ongoing flooding, which lead to rising of the cost of design, construction, maintenance, and operation. After that, the change in policy and regulation. In order to combat climate change, governments all around the world are implementing policies and regulations. These actions include carbon pricing, stricter environmental standards, and emission reduction target. Carbon pricing is a policy tool that is used to measure to reduce carbon emission by placing a price on carbon. Based on the emission of carbon dioxide, government or regulatory agencies levy a tax on the carbon content of fossil fuel from oil and gas production activities. The purpose of the carbon taxes is to encourage business and individuals to reduce their carbon emission by holding them financially responsible for the environment costs associated with their activities. For oil and gas companies, such rules raise their operating expenses and compliance requirements, thereby requiring them to spend large expenditure in emission reduction technologies, hence decreasing their profitability. Through the taxation of the carbon pricing, government can utilize these revenues to fund climate change mitigation and adaptation efforts, invest in cleaner technologies, energy efficiency measures, and alternative energy sources.
Next, let's move on with the impact of climate change on oil and gas production. The first implication is the risk of disrupting and delaying the operational processes. The change of climate change leads to various extreme weather events such as floods, storms, and hurricanes. These weather events contribute significant threats to oil and gas production, especially in offshore drilling operations. Severe storms, heavy rains, and floods may cause damage to drilling platforms, pipelines, and other infrastructure, resulting in the disruptions of oil productions. Additionally, the vulnerability of offshore facilities gets worse with the increasing sea levels and coastal erosion, which affect the offshore facility and design, thus required for stronger countermeasures to overcome the problem. The second implication is the reduction in performance of the equipment. As the temperature rises, equipment such as compressors, turbines, pumps, and generators may be affected, hence reducing the efficiency of the operations. Not only that, as the efficiency of equipment becomes low, more energy is required, the desired output becomes lessened, and more maintenance is needed, which makes them to be costly. Moreover, these higher temperatures will result in permafrost thawing, which might have a negative impact on the safety of oil and gas production, as well as the transportation infrastructure that is constructed upon it. The third implication is the decrease in fossil fuels energy demand. In order to mitigate climate change and reduce the environmental impact, many companies, including oil and gas, have put high interest and start to invest in cleaner energy transition. The shifting towards renewable energy sources such as solar, wind, hydro, and biofuels may lead to a decrease for fossil fuel demands, including oil and gas. By promoting competition and securing a wider range of renewable energy sources, the demand and price for traditional hydrocarbon-based energy is likely to decrease, hence potentially affecting the oil and gas industry's profitability and long-term viability of oil and gas projects. The last implication is the changes in access to oil and gas reserves. The changing climate can affect the availability and accessibility of oil and gas reserves. As the ice melts, this may open up more offshore oil exploration and allow easier shipping access. However, it also introduces challenges as it changes the sea ice patterns, which make extraction operations riskier and more difficult. Sea ice can significantly hinder the production and transportation of oil, damaging passing ships, oil platforms, and oil pipelines, resulting in frequent oil spills. Due to the opening of the Arctic route, resource development, and the rise in the number of Navy vessels in the ice areas in the North China Sea, increases the danger of oil leaks in the sea ice area.
Now we move to the impact of climate change on oil and gas supply chain. The first impact is air and ocean temperatures. Power generation and LNG liquefaction are two oil and gas processes that are impacted by air and ocean temperatures. Higher temperatures typically have a detrimental influence on efficiency, making the extraction of oil and gas more energy intensive. Increased heat stress on outdoor workers also contributes to potentially dangerous circumstances, shortened workdays, and decreased productivity. This session is also focused on ocean circulation, especially in recognizing possible changes in larger-scale circulations. The second impact is water shortage, as it can cause as much damage as flooding. Changing precipitation patterns and air temperatures have the potential to have an impact on river runoff volumes, particularly seasonal patterns, and to drastically alter the amount of water recharging dams. The sustainability of water supplies in many locations may be impacted by this. The frequency and intensity of droughts may be affected by the expected changes in temperature and precipitation patterns. Importantly, dry conditions can raise the risk of wildfire, which can have negative effects on supply chains and infrastructure. Business operations and supply chains can be significantly disrupted by a declining water supply, hence resulting in higher expense. According to McCarthy 2023, he also mentioned that water shortage can lead to power plant discontinuation,
tightening of regulations, and closure of multi-billion-dollar trade routes. Recent droughts have brought attention to how serious the problems are, including those in Southeast Brazil, California, and South Africa. The third impact is sea level rise and ice coverage. The effects of rising sea levels on both the upstream and downstream of the oil and gas industry are significant. The consequences of storm surge and wave flooding become more apparent for feed platforms, coastal refineries, and LNG installations. Key oil and gas infrastructure, including essential pipelines and service roads, is supported in Arctic locations by land ice cover and permafrost. Their capacity to operate safely could be impacted by changes in sea level and ice cover, which could require mitigation measures. The last implication is rainfall and flooding. The infrastructure and supply chain that support a number of downstream activities has been severely impacted by recent high-profile flooding storms in the US, such as Hurricane Harvey in 2017. Arid regions have seen significant flash floods that cause on-site gas production facilities to go down for extended periods of time. An increase in snowfall could affect daily operations and put more strain on buildings. These changes may or may not be caused by a changing climate, but we still need tools that will help us evaluate the design's underlying assumptions using the most up-to-date information and facts.
In conclusion, the company needs to emphasize the urgent need for the industry to prioritize reducing its environmental impact, which can increase global climate change. Climate change is a long-term problem that dramatically affects the oil and gas industry, production and supply chain. Hence, future work needs to be done on how to decarbonize the oil and gas industry.